Hello students. In the previous module, we have studied about the similar triangles. Can you recall when are two triangles said to be similar? Two triangles are said to be similar if their corresponding angles are equal or the ratio of their corresponding sides are same. Now, we will move to a new concept which is related to similar triangles, that is basic proportionality theorem, which is abbreviated as BPT. Let's have a triangle, say A, B and C. Draw DE parallel to BC such that points D and E lie on the sides AB and AC respectively. What can you infer by observing this figure? We see that there are two triangles, ADE and triangle ABC. Do you think these are similar triangles? Yes, these do look like similar figures. Now, using a ruler, let's measure the sides AD, DB, AE and EC. So, we have AD is equal to 3 cm, DB is equal to 2 cm, AE is equal to 6 cm and EC is equal to 4 cm. Can you formulate the relation between the sides so measured? Try to find the ratio of AD and DB and that of AE and EC. Yes, AD upon DB is equal to 3/2 and AE upon EC also comes out to be 3/2. So, we can say that if a line is drawn parallel to one side of a triangle to intersect the other two sides in distinct points, the other two sides are divided in the same ratio. This is called basic proportionality theorem. But how does this happen? How are these sides divided in the same ratio? For this, let's now discuss how basic proportionality theorem can be proved. But before proceeding further, can you infer relation between BPT and similarity? Absolutely correct. We apply BPT in similar triangles only. We will study more about relation between BPT and similar triangle in our later modules. Now, we will prove the theorem. So, we have a triangle, say ABC. Then, according to basic proportionality theorem, we will draw a line DE intersecting sides AB and AC at D and E respectively. And what do we need to prove now? We need to prove that AD upon DB is equal to AE upon EC. Before proceeding ahead, we need to do some construction. We will draw a perpendicular EN from E to side AB. Similarly, we will draw another perpendicular DM from D to side AC. Now, join B to E as well as C to D. Can you recall the formula to calculate the area of a triangle? You have already studied that in your previous classes. Yes, area of a triangle can be calculated by half into base into height. Now, can you tell me the area of triangle ADE? So, we can calculate the area of triangle ADE in two ways, since there are two perpendiculars that we have already drawn. So, area of triangle ADE is equal to half into EN into AD, and it can also be written as half into DM into AE. Observe the triangle BDE and triangle CDE. How do they look like? Yes, they are obtuse angle triangles And also we know that the perpendicular lies outside of the obtuse angle triangle. Now calculate the area of BDE and CDE. Area of triangle BDE is equal to half into BD into EN. Area of triangle CDE is equal to half into CE into DM. Do the triangles BDE and CDE have some relation in terms of area? See, they are on the same base DE and are in between same parallel lines DE and BC. We have already studied earlier that two triangles on same base and between same parallel lines have equal area. So, what did you conclude from it? Area of triangle BDE is equal to area of triangle CDE. Now we have half into DB into EN equal to half into CE into DM. Mark this as equation 1 and half into EN into AD is equal to half into DM into AE. Mark this as equation 2. Now, observing these 4 figures and 2 equations, how can we infer relation between the sides AD, DB, AE and EC? Correct. Divide equation 2 by 1. After cancellation, we have AD upon BD is equal to AE upon EC. Hence, our basic proportionality theorem is proved in this module.